I am Dr. M. Anwar Sadi from the Department of Chemistry, Jamal Muhammad College. The C content explains the different quantized forms of molecular energy levels and molecular spectra. By the end of this module, learners will understand the importance of molecular spectra and recognize the different forms of molecular energy levels. Now, I will explain each concept in detail. Molecular spectra. It is the study of how electromagnetic radiation interacts with molecules. During this interaction, changes takes place in the rotational, vibrational, and electronic energy states of molecules. Why molecular spectra originate? Molecules have quantized energy levels, namely translational, rotational, vibrational, and electronic. When electromagnetic radiation interacts with molecules, it causes transition between these discrete energy levels. As a result, molecules absorb or emit radiation at specific wavelengths. Then we get molecular spectra. Importance of molecular spectra: identification of molecules. Each molecule has a unique spectral signature, which helps in detecting and analyzing them. The second importance is understanding the molecular structure. Molecular spectra provide information about bond length, bond strength, and molecular geometry. These are some specific applications of molecular spectra in different disciplines. In particular, chemistry, molecular spectroscopy used to determine the purity, molecular structure, and composition of compounds. In physics, it helps to study the energy transitions and also supports quantum mechanics. In pharma, that is medicine, they have important role for detecting biomolecules and monitoring drug metabolism. In astronomy, they helps to identify molecules in stars, planet, and interstellar space. This is the pictorial representation of the quantized forms of different energy levels in a molecule. Quantization means that all these energy levels have specific discrete values, not continuous. Each molecule has 4 types of molecular energy levels, namely translational, rotational, vibrational, and electronic. Now, let us explain them one by one. Translational energy. It is represented by the symbol E trans, T-R-A-N-S. This is the energy due to the motion of the entire molecule as it moves through space. This corresponds to give rotational energy. E trans is equal to half mv square, where E trans is equal to translational energy, m is equal to mass of the molecule, v is equal to velocity of light. Similarly, rotational energy, it is represented by the symbol of EROT. Rotational energy is associated with the rotation of the entire molecule around its specific axis. According to classical theory, the rotational energy is equal to half I omega square, where I is equal to moment of inertia of the molecule, omega is equal to angular velocity. According to quantum theory, rotational energy is equal to h nu divided by 8 pi square I j into j plus 1, where j is a rotational quantum number. The meaning of j is equal to 0, 1, 2, 3, that is the integer value. I is equal to moment of inertia, h is equal to Planck's constant, nu is equal to rotational frequency of a molecule. Transition between rotational levels occur when molecules absorb or emit microwaves radiation. At the time of interaction of microwave radiation in a molecule, change in rotational energy levels alone. Similarly, vibrational energy is represented by EVIB. Vibrational energy is associated with stretching and bending of chemical bonds. Vibrational energy, according to quantum mechanics, the formula is E vibration, EVIB equal to h nu V plus half, where V is equal to vibrational quantum number. It has a definite meaning. V is equal to 0 or 1 or 2, etc. H is equal to Planck's constant. Nu is equal to vibrational frequency of a bond. Transition between vibrational levels occur when molecules absorb or emit infrared radiation. Fourth one, electronic energy. It is represented by EEL. This energy is associated with the transition of electrons between molecular orbitals. That is, E electron is accompanied to form E rotational and E vibrational. Transition between electronic energy levels occur when molecules absorb or emit UV visible radiation. The total molecular energy is represented by E total. It is the sum of the product of E translational, E rotational, E vibrational, and E electronic energy levels. The increasing order of these energy levels are: E translation is always less than E rotational. E rotational is always less than E vibrational. E vibrational energy is always less than E electronic. Similarly, change in molecular energy means delta E total is equal to the sum of the product of change in translational energy, change in rotational energy, and change in vibrational energy, and change in electronic energy. That is the sum of the product of change in these four above energy levels. We know that according to Planck's quantum theory, E is equal to h nu. Now rearrange the above equation, nu is equal to E divided by h. Substitute these values in this equation. Finally, we get nu is equal to change in delta E translation energy plus delta E, change in energy, rotational energy, plus change in vibration energy, plus change in electronic energy divided by h. Here, E translation energy is very less when compared to rotational, vibration, and then electronic. Therefore, spectroscopical point of view, translation energy is neglected. Thank you very much.